All right, cool. This is a video talking through how to design using master geometries, child geometries, and derived components. I'm going to use Payload 2025 as the example, and the master geometry and child geometries that I'm going to create are actually going to be the geometries we're going to move forward with design-wise. So this is all very representative of what we are going to actually be dealing with. So first of all, I'm currently connected to the server. I'm going to go into 2024, 2025, payload, and I'm going to create a new version. We'll call it version 2. And we are now starting absolutely fresh. We're going to be referencing no external CAD. I'm going to take some shortcuts here just for the sake of brevity. Otherwise, this video would be an hour. But yeah, this is what we will ultimately work off. So now that I've a fresh version, I'm going to go into SolidWorks and create a new file. And this is going to be our master geometry. So first step is making sure that our units and display are proper. So under dimensions, we're going to change this to 123 precision. That's just going to show that all of our dimensions or show all of our dimensions in thousandths of an inch, which is representative of the tolerance that we can machine to. And then unit should be inches, pounds, and seconds. With that, I'm going to save this as our master geometry. So going back into that previous folder, go to V2. I will save this as following our naming scheme. We have G for geometry, Cornell Rocketry, 0000, master geometry, and hit save. So now this is our master geometry. Everything in our system, and I mean everything, is going to be derived off of this single part file. And so it's very important that you take it's important you have good CAD practices everywhere, but this is most important. First thing I'm going to do is create this front sketch. This is the plane containing the most critical information. And for the sake of brevity, I will try and be quick, but we know that we have a nose cone, which is a simple spline of this nature. So I'm going to start setting all this up. We can draw a line. I'm going to use this for all of my mirroring, turn that into construction geometry. I'm going to mirror this spline across and make these guys vertical and make these horizontal, make these horizontal. So right now I'm setting up the nose cone, and we know that the airframe inner diameter is 6 inches. And then we can offset this guy by 0.1 thickness of our airframe. We will also mirror that offset to the other side. Actually, I'll mirror everything at the end. Connect these guys. Lovely, lovely. We know the nose cone is 36 inches long. And then the last bit is just adjusting these handlebars. In the actual version, I will lock all of these um, dimensions down to make sure they accurately reflect um, the real nose cone geometry. But for now, this is good enough. So that looks close enough to the nose cone. Again, I'm going to adjust all this later. So now I can come down and start. Well, actually, first I'm going to mirror everything. So come up here, select that, mirror about this central. Cool. Now I am going to create the upper airframe section. So I'm going to make this coincident with that. And this point should be coincident with this point. Voila. And we can set this height equal to 12 inches. Cool. And then we also have our coupler. So we know our coupler is going to be collinear with the bottom airframe section. And we know that it'll stick up past the seam 5 inches and stick, and it's a total of 1 foot tall. So we can set that to 12. And we know it is also a tenth of an inch thick. There we go. Lovely. Perfect. And now I will mirror both of these about Cool. Okay, so at this point, my cross section contains the cross section of the nose cone, the cross section of the coupler, which are these two, as well as the cross section of the upper airframe section. Now, the last thing I'm going to define is the actual payload itself. So I am going to draw a rectangle. I will make this vertical, so it is aligned within the center. And we know that the bottom of payload, making this number up because I don't have it memorized, but call it 7 inches off that section. We have it defined, and that's an agreed upon number for structures. We know the overall payload is 40 centimeters tall, and we know the overall payload is 10 centimeters wide. So there we go. We now have payload defined. We have the airframe sections defined, and I'm also going to actually, for the sake of this video, I think the coupler is 10 inches. Lastly, I'm going to create that bottom bulkhead. So here's an example of what I was talking about before in terms of reflecting constraints. So it's not a huge deal, but I prefer to use collinear relationships when possible. That just makes hunting for relationships easier later on. So it's not associated with a corner. It's actually associated with the edge. So I'm going to select these two edges and make them collinear and repeat that process for over here. This bulkhead is 0.5 inches thick. We know that the hole is going to run through the middle. So I will create this. And actually, this is where I can use the select other tool to select that. We can make that a midpoint and repeat the process over here. Perfect. Okay. And then the last step is making this collinear. So at this point, this, oh, and then up top, let's define our tip. So we have our tip coming up here, and I'm gonna make this kind of a little bit janky, but just to drive home a point. Um, Perfect. And then uh, let's see. I will mirror that across the center axis, and um, that is looking pretty good. We also have the nut technically in the actual version. I think I can neglect that. So at this point, we've created a master geometry. I think what I'm going to do is rather than flesh this out further, I will instead focus on some other aspects that I think will illustrate master geometry better. So what I'm going to do is exit this sketch for now. Make sure to name every sketch that you create in master geometry. So this is, we'll call it airframe section front. So in parenthesis is the plane that it was sketched on, so the front plane. And airframe section is pretty descriptive. This is really the most fundamental sketch we have, and this will kind of drive all the dimensions afterwards. Um, Now, what I want to illustrate is how master geometries will have multiple sketches in different planes. So I'm going to create some reference geometry, a plane. It's going to be perpendicular to that center axis, and it's going to run through the top of the bottom bulkhead, so that line. Now notice I had two choices here when I could have selected. I could have either selected the bottom of payload or the top of bulkhead. Again, because those are collinear, it will result in the same plane now. But if for whatever reason the bottom of the payload becomes divorced from the top of the bulkhead, maybe we end up putting spacers in there or a vibration damper, that will end up impacting which where that plane ends up. And so when you make the decision of which line to use as your reference geometry, you need to think about what you are like what you are exactly targeting. So I'm going to explicitly draw the top of the bottom bulkhead rather than the bottom of the payload. And that is a minor difference that doesn't manifest itself in this, you know, without editing it, but it means if you're thinking about those things, you will create CAD that is far more robust to changes in the future. So anyway, with that out of the way, I've now created a plane. Be sure to adjust your planes to reflect what they are actually like the area that they are kind of defining or relevant over. I hate when planes are off in the distance and doesn't help clarity. I'm going to create a new sketch on that plane, and now I will begin projecting. So first of all, I can use the Convert Entities tool to project in the inside here. That's perfect. Oh, you can only project. Oops. You have to project in points. You cannot project in lines. So we will send those in. Perfect. Now, an important thing to do is hide sketches once you're done with convert entities. That makes sure you don't accidentally reference geometry that you haven't explicitly converted in. That avoids you making association errors. So I'm now drawing a circle. I made it coincident to the origin, which we know is through the middle. And then I will make this coincident with one of these. Strictly speaking, you only need to import one. I imported both just for uh, basically sake of habit, but doesn't really matter. So this is now the inside of our airframe. If we turn this back on, we probably also want the outside. So I'm going to project in those two as well. So convert entities. We can select these 2 points. And then lastly, while I'm here, I'm going to project in the payload. Again, hiding this, I'm going to create a circle now. Once again, make it coincident there. And then we know our payload is going to be along here. We'll make that a midpoint. This is a midpoint. And then we know payload is equal in both dimensions. So look at that. We have not typed in a single dimension for this sketch, and we already have all the kind of 2D info here. But the reason I'm drawing this is now we can begin to define some other features of this bottom bulkhead. So for example, I want 4 radial holes that we're going to use to mount the bulkhead to the airframe, and I want each of them to be 3/4 of an inch deep. And so I can kind of sketch that out. I'll use this. Cool. And the reason I am sketching with a dotted line is because it's out of plane. So this is technically the top of the bottom bulkhead is the plane of the sketch, but the holes that are going into the bulkhead are actually halfway through the thickness of the bulkhead. And so I'm using construction geometry to highlight the point or the fact that that basically these are not technically within the plane that I'm sketching in, but it's still important information that I need to reference. And yeah, not all construction geometry means that, but if you are drawing out of plane stuff, you should make it into construction geometry. And then here I'm going to define that we are using 1/4-20 holes. I use this line just because it makes things a little bit easier, but there's many ways to create this. And then lastly, I'm going to do a circular pattern of these elements here. Perfect. Our point will be here. Great. And we have 4 of them equally spaced. Press check. You're going to notice these are defined. Perfect. That's exactly what we wanted. So at this point, we now have a master geometry. It contains 2 planes. One of them is the slice through the middle of the airframe. And this is what I would call the kind of most critical axis or plane perspective. This contains really the most driving characteristics of payload, which is where it actually needs to fit. And then the second was down here, which is defining the bottom bulkhead. Obviously, there is it's less clear what the second most important plane is, but frankly, it's less important. Really, the most important is what you select as your first. We're going to rename this because that's really important. So we're going to do bottom bulkhead top. And we are also going to put top here. Now, this may seem a little confusing at first, but the reason I'm writing it like this is because we are currently sketching from the top perspective. Remember, there's 3 primary perspectives. We're sketching from the top perspective on top of the bottom bulkhead. Now, the reason that's important to specify is because we could theoretically have a sketch down here on the bottom of the bottom bulkhead, also from the top perspective, right? And so you want to be careful with your naming scheme. Just make sure you're including as much information as possible. At the end of the day, it's not all that critical. Okay, so at this point, we have our master geometry. I'm hitting Command S to save it. You can see the star went away up in the corner. I'm also going to hide the plane. That's best practice. You don't want your plane showing, just to make it look nice. I have everything saved, and I will now proceed to start fleshing out some subsystem geometries. So I'm going to create a new, actually, before that, I'm going to go to my File Explorer. So you can now see in our project, we have our master geometry. We want to fill out the rest of the folders that we are going to use going forward with the project. So first, every project is going to have a shared parts folder, and this is where things like bolts and nuts from McMaster that are shared across subsystems will be stored. We're going to create a our 1000 level subsystem, which I'm going to call the airframe. Then we are going to create our 2000 level. And this is where it becomes a little bit less clear, but I'm going to make this into the, I'll call this superstructure. And then if I were to keep going, I will for the sake of demonstration, but we won't actually do all of these. 3000 could be uh, payload internals. And then your 4000 level could be uh, your tip, for example. Generally, if one system depends on another system, for example, we need to design the superstructure for the payload before you can actually design the internals. If that's the case, then you want your internals or whatever system that relies on the other system to be a higher number. So you would design, right, like everything depends on the airframe. So design the airframe first, and then design the superstructure, and then design the payload internals, and then the tip. But it's not terribly important, but that is one thing to note. Okay, now that we've set up the file system and we have our master geometry ready to go, I'm going to begin with the airframe. So typically you would create a child geometry within a subsystem, insert the master geometry, and then begin adding in subsystem specific features to that. But because the airframe is fully defined by the master geometry, we don't actually have to do that, and that saves us a step. And note, this isn't breaking convention. Not all subsystems need child geometries if the master geometry defines it entirely. This typically only applies to really simple subsystems like the airframe. So what we can do is go and create a new part in SolidWorks. Remember, first thing we always have to do is document properties, dimensions, set this to 123, and units are IPS. Hit OK. We are now going to save this. So within Airframe, I'm going to save this as part. Cornell Rocketry created it, 1001, and this will be the nose cone. Cool. So now that we have the part saved, we can insert the master geometry. So I'm going up to insert and then part, and then I'm going to browse, go back, select the master geometry, open that up. And then down here, the only two things we want to insert are the absorbed sketches and the unabsorbed sketches. Everything else we don't care about. So we'll hit check. This arrow will come up. It's totally fine. Just hit yes. And we now have our master geometry in here. Now, what are we trying to do? We're trying to create the nose cone. How do we do that? Well, we simply need to revolve the nose cone around the central axis. So I will do a revolved boss base. I will select here. The axis of revolution is this. Our selected contour is, come on, there we go. And 360 degrees. And voila, right there we have our nose cone. And notice we are revolving the airframe section, which I'll remind you is a sketch imported from the master geometry. Note that in this file, we had to do no sketching. All of the sketching was done beforehand in the master geometry. And if I were to edit the master geometry, this part would update. With that being said, I will now hide the sketch. Always hide your sketches so everything is clean. And we now have our nose cone right here, which is fantastic. Let me make sure I did that correctly before moving on. Everything looks great. Perfect. So with that being said, I will save that. And now let's create a new part. This is going to be our coupler. So once again, same exact process. We need to go up here, document properties, units, inches, pounds, seconds, and dimensions is 123. Hit OK. We're going to now save this airframe part, Cornell Rocketry 1002, and this is going to be our coupler. Awesome. Now under insert, we go to part. We're going to select our master geometry. Scroll down here. The only two things we want are absorbed and unabsorbed sketches. Hit yes. Perfect. Now we have our master geometry and we are going to repeat the same process, but this time for the coupler. Revolved boss base. Select here. The line that we want is this one, and we are going to revolve this. Hit check. That looks correct. This is indeed the coupler. So we will hide the sketch that we used because we don't want that. Make sure both these sketches are hidden. And voila, that is our airframe section. And note that this is, in fact, one solid body. It's just SolidWorks being annoying with displaying. So I will hit Command S and save that. Lastly, we are going to repeat this final process for the upper airframe section. So again, create a new part. Under options, we're going to go to dimensions, 1, 2, 3, units, IPS, hit OK. This point, hopefully have it dialed in. Airframe, part, Cornell Rocketry, 1003, upper airframe section. Perfect. Now we're going to go to insert, part, browse, B2, master geometry, open, hide these two, hit yes. There we go. And lastly, revolved boss base. Select this. Nope, that's not what we want. Select two contours. There we go. That looks great. Let's double check that that looks all right. It indeed does. Looks like we selected the right profile. Perfect. So we're going to hide our sketches. Make sure everything else is hidden. Looks great. Command S. Awesome. So we at this point, let me go back to our file browser. At this point in our airframe, we have our nose cone, our coupler, and our airframe section. It is now time to create a sub-assembly. And that is very, very easy. So we're going to go to new. This time we're creating an assembly, not a part. Let it load. Now, the first thing you always import into any assembly, whether it's the master assembly or a child assembly, is always the master geometry. Every part has a master geometry. It's just good practice to always have it in there. The important thing is when you import it, make sure to click fix. This is going to fix it in the same place that it was in its own original file. This is super, super important. This means that every single part you ever work on for a system will be in the same coordinate system, which is makes life really, really easy. So we're going to hit check. You'll see it automatically moves to its home coordinate system. If we try clicking and dragging, we can't move it anywhere. That means it's fixed in place. Now, this is the beauty of designing with master geometries. All we need to do to build an assembly is come to insert components. We're going to go to airframe. We'll click on nose cone, open, scroll down here, make sure that it's fixed, press check, and voila, it's in the exact correct place. We can't move it, we can't drag it. So we'll repeat that same process. This time, we'll add the coupler. Again, make sure that it's fixed, press check, and it's now, what would you know, but in the correct place. So lastly, insert components, browse, upper airframe section, open, make sure that it's fixed, press check. Well, you got it. There we go. Sometimes takes a few clicks just to load in. And we have now, if I hide this master geometry, so I come in here and hide these two sketches. Oops. We have now created an assembly. It's all defined in the correct place in literally 15 seconds. It is super, super easy and you don't have to think. There's no mating involved. Everything just falls into place. So I'm going to save this. It's going to ask save all, press save all, and we are going to save this into airframe, and I will save it as A for assembly, Cornell Rocketry 1000, and this is airframe assembly. Okay, so at this point, we have our master geometry. We have nothing in shared parts. We have our nose cone coupler and upper airframe section, as well as the airframe assembly. The next thing I'm going to move on to is creating the bulkhead for the superstructure. I'm not going to bother with any other components. So after that, I will just leave it. So if we come into superstructure, you can see we have nothing here. I'm actually going to create a child geometry to demonstrate what that looks like. And then we will move on from there. So First, let's come back to SolidWorks. We're going to create a new part. Remember, first thing you always do, set your document properties to dual precision is 1.23, our primary is, and inches, pounds, seconds. And we are going to save this under the superstructure as G for geometry, Cornell Rocketry, 2000. And this is our superstructure geometry. Hit save. Perfect. Now we can insert our master geometry. So we go up to insert part. I'm going to select the master geometry, hit open. Now, before I mentioned we only insert the sketches and unabsorbed sketches, I actually misspoke. You also want to insert the planes. This will allow us to create sketches on the same planes that we are using in the master geometry. So I misspoke earlier. Always insert the planes as well when you are inserting a geometry. Yes. And voila, we now have the original planes from our master geometry as well as the two sketches. They're just hidden because I turned them off in the master, but we can turn them back on in this part. So what we want to do right now is define the subsystem specific details for the bulkhead. And so for this sake of this, I'm going to keep it kind of quick. I'll do some basic mass reduction. So I will create a sketch on the same plane. So notice this is a plane that we created in the master geometry to make this bulkhead top sketch. So I can actually reuse that plane, create a new sketch on it, and then I'm going to project in. So I'm going to use that convert entities. There we go. Convert entities. I'm going to select the bulkhead. Remember, this is the outside of the bulkhead. This is the outside of the airframe. So select that. Perfecto. And now I'm going to turn off these. Cool. And the last thing I'm going to do is just some simple mass reduction. So maybe we'll, oops, that's not what I want. Maybe we'll put like a circle in the middle and just hollow that out on the insides, and we'll make that 3 inches. Perfect. Okay. So I know this is some basic mass reduction, but the point still stands. So we now have this kind of refinement to our original master geometry, but these refinements really only impact the bulkhead itself. It doesn't have any impact on the rest of the system, and that's why we're creating in a child geometry. For more complicated systems, it becomes more obvious why you want to segregate this different information. Again, because it's a geometry, we do need to name our sketch plane. So we're going to call this bulkhead top or bulkhead mass reduction, and it's from the top perspective. Perfect. Save that. Now we are going to go on to actually create the bulkhead. So we'll go File, New, Part, Options. We'll go to Document Properties, Dimensions, 1, 2, 3, Units, IPS, hit OK. And this is going to be our part file for the bulkhead. So we'll save this as part, Cornell Rocketry, 2001, and this will be bulkhead. As you hopefully know at this point, insert part. We're going to insert, this time, we are not inserting the master geometry. We're inserting our child geometry, which if you ever get confused, you go to 2000 superstructure. We're going to go to superstructure geometry, open. Remember what I said before, the only 3 things we want are planes, absorbed sketches, and unabsorbed sketches. Check. Yes. We now have our sketches. I can show all of them to demonstrate they're all there. Really, the only ones that I care about are these bottom 2, but for now, we can actually just get away with using this. So what I'm going to do is simply extrude this. So I will extrude this. And actually, I do need this sketch to show the thickness. So this demonstrates extruding to a vertex. So we are going to repeat that process. I'm going to select this ring right here. And instead of blind, you are never going to use a blind again, pretty much. We are going to extrude to that thickness that we defined in the master geometry. And you can see now that this entire shape, the shape of the bulkhead, is in fact defined by the master geometry, just kind of with those two sketches, which is quite neat. We can now create the 4 radial holes. So this time I'm going to turn on this top sketch. We don't need our mass reduced sketch anymore. So make sure you only have the sketches that you need turned on. We can really use any of these. I'm going to use the one we started with because that's just kind of the most intuitive. And we need a plane that is out here to actually create that hole. So what I'm going to do is turn on the, let's see, yep, the right plane. So we're going to create reference geometry plane. It'll be parallel to that front plane and it will be coincident with this point. We can now create a sketch on this plane. Perfect. So we're going to come around here and I'm now going to convert entities and bring in these 2 points right here. Cool. And then I'm also going to bring in the midline right here, which we said earlier would be the center line for the holes. So I will convert entities there. Perfect. Now we're going to hide all of these sketches because we do not need them anymore. Now I will draw the hole and I will make sure I will add 2 points. And this way I am using the projected geometry to actually define that size. So notice, again, I will remind you, this geometry from the master geometry is being imported and that is driving the size of this hole. So if we were to change the width of this rectangle, we would actually update this hole in this child geometry. We now have this sketch defined. I'm going to hide the sketch. Again, always hide your sketches if you're not using them. Go here, select this sketch, extruded cut. And this time we need to extrude it to the depth here. So we will actually turn that back on, extruded cut, and it is up to vertex. And we will select this back vertex. Perfect. And hit yes, that looks great. And then lastly, we're going to do a circular pattern of that feature. We can select, let me select the outside here. And we have 4 of them equally spaced. Perfect. Great. So we now have our full 4 holes. I'm not going to bother with threading, just for the sake of brevity, hide this. And so make sure to hide your planes too. So we've now created our bulkhead. We'll hit Command S. Now, because we only have one component right now, we don't actually need to create a assembly. So for that reason, we don't need like a superstructure assembly. However, the moment we start adding more parts, we would create a superstructure assembly. But for the sake of time, I'm not going to do that. So the last step that before I kind of close this off is to create the master assembly. So I'm going to create a new assembly. And this will allow us to combine the airframe and the bulkhead. I'm going to browse. Remember, the first thing you always import is your master geometry. Open. Perfect. Make sure it's fixed. Hit the green check mark. Note that it's hidden so we can come through and we can now see our master geometry right there. Looking great. I'm going to turn these back off. I'm actually going to suppress the feature. Well, I guess I can just hide it. And that way I don't really like the look of sketch elements with parts, but that's personal preference. Now we're going to go to insert components. Then we can browse, go to the airframe and insert the airframe assembly. No, we've already actually like assembled the sub-assembly. So when we insert it, it lands in the perfect spot. Notice that there's a few sketches turned on. This is not the end of the world. We can turn them off. There. Cool. Save all. And I'm going to now save this master assembly. So go back to the highest level, out to the same level as the geometry, and we're going to save it as a Cornell Rocketry 0000 master assembly. Perfect. And then the last part is just inserting that bulkhead as well. So we can go back to insert components, browse, superstructure, bulkhead. Again, if we had a superstructure sub assembly, we would insert that, but we don't because we only have one part right now. I just haven't had time to cat it. Hit open, make sure that it's fixed, hit the green check mark. Sometimes you have to hover your mouse over and have it move around with you before it works. Hit the green check mark, and our bulkhead has now inserted in the exact correct place. And so at this point, we now have, if we go back to our file explorer, we have our master geometry and our master assembly. From that, we have several different systems. Each one has their own unique set of 1,000 kind of identifiers. Within the airframe, we have a set of three components, which are all completely defined by the master geometry. And then from that, we have created an assembly. And then that is a subassembly for the airframe itself. In the superstructure, we've created a child geometry, and that child geometry offers a even more refinement and for the part specifically, or for the subsystem, I should say. In this case, we only have one part, but if we were to have multiple parts, the superstructure geometry would define like what size threads and bolts are actually holding those parts together. What are those dimensions of those parts? And then we have our bulkhead defined off of it. And then we have our master assembly, which includes both the airframe subassembly and the bulkhead imported into one part. Now, the final thing I want to show you is how updates propagate. So right now I have all of our designs open. I'm going to go back to our master geometry. And let's say we are now using an 8-inch rocket. So how would we edit that? Well, we come back to our master assembly. I guess I didn't end up using the nose. That's okay. And I'm going to come down here and find this dimension, which is in fact 6. That's what is defining the ID of our rocket. I'm going to come in here and simply hit 8. Voila. So now you can see the sketch will obviously update because that's kind of the way we've drawn it. And when I hit exit sketch, you'll see that let's turn these back on. So obviously the sketch we just edited changed, but the bulkhead also has changed. So the bulkhead is now adapting to that 8-inch because we converted entities, we projected those features in. Now, the important thing I need to do, you can see up here how there's a little star next to the name. I need to hit Command S to save. And now that it's saved, watch. When I open the nose cone, you'll see it takes a little bit to process. It now updates. And you can see when it updates, when you opened it, it is now has a star. It means that it's been basically updated using that new geometry. So you actually need to save. So hit Command S. I can now open the coupler. You can see the coupler has also updated. And I can go through all these. Now, note that if you don't have them open, which actually in best case scenario, you have nothing open, you have as few files open as possible. When you go to an assembly, the assembly, SolidWorks will in the background update all of the parts for you and then include all of those parts in the assembly. So the best way to update all of your parts and make sure they're up to date is to simply open the master assembly and it will handle it all for you. So I'll show you that in 1 second. But just to prove the point, we can now come through. You can now see the airframe section is good. I'm going to hit Command S, save that. And now you can see the airframe section. Assembly is going to ask or tell us that, parts have changed. Do we want to reload? And we say yes. So it'll load them through and we can now see it is properly accounting for the 8-inch ID. I'm going to hit Command S to save. And then let's go to the superstructure geometry. Remember, this is a child geometry. If we turn this on, you'll see that indeed we are now using the updated master geometry. So I can hide that again. I'm going to go back or make sure I save, go to the bulkhead, and voila, the bulkhead is updated. Command S. And finally, if we go to the master assembly, we'll get the same comment as before. And look at that. We have 8-inch airframe with a single edit and absolutely no issues.